Hello, good afternoon. My name is GMA Tajos. I'm with Ma'am Maria Reina Herman and Ma'am Hannah Marvin Dizon, and we will be reporting about the coastal geography. Coastal geography is the study of the constantly changing region between the ocean and the land, incorporating both the physical geography and the human geography. The coast is the land along a sea. The boundary of a coast where land meets water is called the coastline. And a coastline for seashore is the line that forms the boundary between the land and the ocean waves. Tides and current helps create coastlines. Coastal zones. The coastal zones includes all areas from the deep ocean up to 300 kilometer offshore to 60 kilometer inland. At the coast, there is the upper beach or the backshore, backed by the cliffs or sand dunes. The foreshore periodically exposed by the tides, and the offshores are covered by water. The coastal zone is a dynamic area with inputs and processes from the land and sea. Then wave, marine, and subaerial processes. Waves are a medium through which energy is transferred. They are created by the wind blowing across the surface of the sea. Frictional drag increases as the wind speed increases, making wave bigger. Wave energy depends upon three things: the strength of the wind, the length of the wind, and the length of the time the wind has blown for, and the third one is the fetch of the wind or the distance it blows over. The wave orbit. The wave orbit is the shape of the wave varying between circular and elliptical. The orbit diameter decreases and depth thoroughly equal to the wavelength, at which point there is no further movement related to the wind energy. This point is called the wave basis. Wave definitions. Wave fetch, the distance of open water over which a wave has passed. Wave crest is the highest point of a wave. Next is the wave throw, lowest point of a wave, and the wave height is the distance between the throw and the crest. Wave length is the distance between one crest through and the next. Swash is the water movement up a beach. Backwash is the water movement down a beach. So there are types of breakers. Plunging breakers tend to occur on steeper beaches with waves of the intermediate steepness. They are distinguished by the shoreward face of the wave becoming vertical, curling over and plunging forward and downward as an intact mass of the water. Next is the surging breakers. Are found on steep beaches with low steepness waves. In surging breakers, the front face and crest of the wave remain relatively smooth, and the wave slides directly up the beach without breaking. Once the breaker has collapsed, the wave energy is transmitted onshore as a wave of translation. The swash will surge up the beach with the speed gradually lessened by frictions and the uphill gradient. Gravity will draw the water back as the backwash gradient. Here's the illustration of a breaker waves. Next is the waves of translation. Constructive waves. A constructive waves have a short amplitude and a long wavelength. They have a low frequency of around 6 to 8 waves per minute, particularly when these waves advance over a gently shelving seafloor form form of fine material sand. These waves has been generated for offshore, creating a gradual increase in friction and thus a gradual steepening of the wavefront. This creates a spilling breaker where water movement is elliptical. As this breaker collapses, the swash surge up the gentle gradients and maximum energy. Constructive waves produce a strong swash but a weak backwash, which produces a gentle beach as material is deposited but not removed from the beach. The supply of a new material and the constant action pushing the materials and the beach eventually produces berms. The processes and the landforms in coastal areas. So wave dominated, so shore platforms, cliffs, beaches, splits, deltas, so high energy. Tide dominated, mudflats, sandflats, salt marshes, mangroves, and deltas, low energy na siya. Then Wind dominated is the sand dunes, high energy. Tides and the tidal cycle. Tides are regular movements in the sea surface, the rise and the fall of the sea level caused by the gravitational pull of the moon and the sun on the oceans. Out of the two, and the moon accounts for the larger share of the pull. When the earth, moon, and sun are aligned in a gravitational pull, it is greatest. This creates a spring tide. A spring tide results in a high tide, and low tide. This creates a high tidal range, difference between the highest and the lowest tide. Low spring tide occurs just after a new moon, whereas high spring tides occurs after a full moon, when the sun and moon are aligned. When the sun and moon are at the right angle to the earth, we experience neap tides. The gravitational pull of the sun partially cancels the moons. This results in a low, high tide and a high, low tide. This creates a low tidal range and results in a weaker tidal currents than normal. Next is the what influences tides. So this what influences tides? Tides are influenced by the size and shape of the ocean basins, the, the characteristics of the shoreline, Coriolis forces, and meteorological conditions. In general, tides are greatest in bays and along funnel shapes coastlines. In the North Hemisphere's water is deflected to the right of its path. During low pressure system, water levels are raised 10 centimeters for every decrease 10 MB. Tides and the tidal cycle. The difference between a high tide and a low tide is called the tidal range. Tidal range varies with distance from the amphidromic point, place where there is no tidal range, and in accordance to the shape of the coast and the strength of the tidal currents varies enormously. In the coast is funneled, a tidal bore can be created due to tide advances being concentrated in a narrow space. Coastal areas can be classified into microtidal, very low on tidal range, less than 10 meters, a mesotidal, 2 to 4 meters, and a micro, over 4 meters. Rip currents are strong offshore flows and often occur when breaking waves push water up to the beach face. This piled up water must escape back out of the sea as water seeks its own level. Typically, the return flow backwash is relatively uniform along the beach, so rip currents aren't present. However, if there is an area where the water can flow back out of the ocean more easily, such as a break in the sandbar, then a rip current can form. When water from the highest sections of breakers travels upshore, often upon returning as backwash is moved through the points where lower sections have broken, creating a strong backwash current. Once rip currents are formed, they modify the beach by creating costs which perpetuate the currents. Discordant coast. On a discordant coastline, alternating layers of hard and soft rock are perpendicular to the coast. Because the soft rock is exposed, it is eroded faster than the hard rock. These differentiate erosions create headlands and bays along discordant coastlines. Concordant coasts have alternating layers of hard and soft rock that run parallel to the coast. The hard rock acts as a protective barrier to the softer rock behind in preventing erosions. If the hard rock is breached through, the softer rock is exposed and a cove can form.